Today, we're diving into pneumatics. It's this incredible, invisible force that powers so much of our world, from giant factory robots all the way down to the doors on a city bus. And it's all driven by something we literally just breathe in and out every single day. You ever just watch a complex machine at work and wonder, how? How do those robotic arms grab and twist and place things with such perfect timing over and over again? And they never seem to miss a beat. What's the secret sauce behind all that power and precision? Well, you might be surprised to learn that a lot of the time, the answer is just air. Seriously, not just any air, of course. We're talking about compressed air that's being controlled by a whole system of really clever parts. And today, we're going to break down exactly how that hidden power gets put to work. Okay, so the best way to wrap your head around a pneumatic system is to think of it like a body, right? Every single action has to start with a thought, a command that comes from the brain. So let's start there, with the brains of the whole operation. Every single one of those powerful movements, every push, every pull, every clamp, it doesn't start with a big bang. Nope, it begins with something more like a whisper, just a tiny little electrical signal carrying an instruction. And this right here, this is the brain. It's called a PLC, a programmable logic controller. You can just think of it as mission control. It's got a whole set of rules programmed into it, and when certain conditions are met, it makes a decision and sends out that tiny electrical command telling everybody else what to do next. But here's the thing. That little electrical signal can't do any of the heavy lifting. It's just a message. That message travels to this device, a solenoid valve. This thing is basically the gatekeeper. The electrical pulse tells the valve, hey, open up, and it throws open the floodgates to unleash the real power, a huge blast of compressed air. So the brain has given the order. The gatekeeper has opened the gates. But now, how does all that powerful air actually get to where the work needs to be done? Well, for that, you're going to need a network. I mean, how do you get that force from point A to point B, especially when point B is way on the other side of some complex machine, and you got to go around corners and through all these tight spots? Well, the answer is all this flexible tubing. This stuff acts like the system's circulatory system. Just like the arteries and veins in your body carry blood around, these tubes carry compressed air, delivering all that power exactly where it needs to go. And of course, it's not just one long, straight tube. This network is built with a mind-boggling variety of connectors and splitters and elbows. They're called fittings. They are the joints of the system, letting it bend and twist and send air anywhere it needs to go, connecting everything together. Okay, so we've sent the command, we've transported the power through the network. Now for the fun part. It's time to actually put that power to work. It's time for us to meet the muscles of the system. This is a pneumatic cylinder. You might also hear it called an actuator. But this is where the magic really happens. It's the part that finally turns that invisible force of air into actual physical work. The compressed air rushes in, it pushes a piston, and that moves a rod to push or pull or lift or clamp something in the real world. And, just like in our bodies, not all muscles are created equal. The little compact cylinder on the left, that's built for speed and for fitting into really tight spaces. But the big one on the right, that's the power lifter. It has a much larger piston, so it can generate way more force for those heavy-duty jobs. It's all about picking the right muscle for the task. So a system with a brain and muscles is pretty cool, but without any senses, it's basically just operating blind. To be truly smart and, more importantly, safe, it needs to be able to see and feel, and sometimes be controlled by a human hand. Just think about it for a second. How does the brain know if the muscle actually did its job correctly? How do you know if there's enough pressure in the system to work safely in the first place? You have to have feedback. You need senses. And what's really cool is you can see the evolution of these senses right here. On the one hand, you've got your classic old-school analog gauge. Simple. A person walks up, looks at the needle, and knows the pressure. But on the other hand, you have a modern electronic transmitter. This thing doesn't just show the pressure, it actively reports it straight back to the brain, that PLC we talked about, so the system can make adjustments on the fly. But for all this incredible automation, for all the smart brains and all the advanced senses, sometimes you just need something way, way simpler. These are the hands of the system, manual valves. Their job is dead simple, but it is absolutely critical. They just let a person walk up and, with a flick of a lever, physically shut off the flow of air. For safety, for maintenance, for just basic operations, you can't beat the simple reliability of direct manual control. And don't mistake simple for weak. I mean, look at these specs. This valve can handle 30 bar of pressure. That's over 400 psi. And look at the temperature range, from way below freezing to well above boiling. This isn't just a simple tap. It's a seriously rugged piece of engineering, built to work perfectly in some of the toughest places on Earth. So we've got our brain, we've got our circulatory system, we've got our muscles, and we've got our senses. All right, let's put this whole thing together and see this amazing body come to life. Let's trace it one more time, from thought to action. Number 1, the PLC brain sends out a little electrical spark of an idea. 2, the solenoid gatekeeper gets the message and throws open the gates. 3, the compressed air rushes through the network of tubes. 4, the cylinder muscle does the heavy lifting. And 5, all the while, the senses are monitoring everything, feeding info back to the brain. It's a perfect loop. And the absolute beauty of this system is that these exact same principles apply everywhere. They're what power those incredibly complex robots on an assembly line, and they're what power the simple air gun a mechanic uses to clean off a part. The scale changes, but that core idea, brain, network, muscle, it stays exactly the same. So that's pneumatics. It's the art and science of taking something as simple and as common as air, putting it under pressure, and then using a smart system to control it, turning that invisible force into real, tangible work that actually shapes the world all around us. So the next time you hear that psst sound from an automatic door, or the brakes on a bus, or you see a factory at work, you're going to know the secret. You'll actually see the system. So my question to you is, now that you know what to look for, where else are you going to spot this hidden power at work?